In this problem, we're doing something called finding the linearization of a function at some value. And linearization is a big word, but it's a pretty simple concept, and we've kind of talked about things like this before. If you have some function, maybe it's doing something like that, and you want an approximation for the values near an area, you can draw a tangent line. So let's say this point we're interested in, or point's very close to it, and we draw a tangent line there. Well, that line is going to be a pretty good approximation for values close to that point. The farther away you get, the further it gets from the function. But right around there, it's a pretty good approximation. So we'll do a linearization to get a basic idea of values around that area. What a linearization looks like then is actually the formula for the tangent line. And that we can use some calculus to figure out pretty easily, right? The derivative of a function is going to give us the slope at that point. And then if we have a point on the function, we can figure out the formula for a line. And that's exactly what we're being asked to do here. It says, given this function, let's see, x minus x cubed times 1 minus x, find L of x. And that's their shorthand for the linearization. So that's going to be the formula of a line at the value a equals 2. So I think the first thing I'm going to want to do is take the derivative, and actually I don't want to use the product rule here and use substitution. I think what I'm just going to do is multiply all this out. I think that's just as easy. So let me go ahead and FOIL this first of all. So I've got x and then negative x squared and then negative x cubed and then positive x to the fourth. Whoops, x to the fourth. Let me just rewrite that in order. X to the fourth minus x cubed minus x squared plus x. So that's f of x. All I did was FOIL that. F prime of x, we're just going to apply the power rule. So 4x cubed minus 3x squared minus 2x plus 1. So that is our derivative of the function. We want to find the linearization, we want to find the linearization at the value a equals 2. So that's the value we're going to plug in for x in the derivative to calculate what the slope is there. So 4 times 2 cubed, which is 8, minus 3 times 2 squared, which is 4, minus 2 times 2 plus 1. So that is 32 minus 12 minus 4 plus 1. That is 17. So our slope is 17. Okay. Now, to figure out the line, we just need a point, and we've got that value 2. We can just plug it into our original function. So that would be 2 minus 2 cubed, which is 8, times 1 minus 2. And 2 minus 8 is negative 6. 1 minus 2 is negative 1. So that is a positive 6 when we multiply them together. So the point 2, 6 is on the line. And now I can just, and on the function, and now I can just do the point slope form here. So y minus 2, y minus 6 equals 17 times x minus 2. So multiplying through the 17 here, we get 17x and minus 34. And then we're going to add 6. And we get y equals 17x minus 28. So that is the equation for a line. That is the linearization of this function at that point. So that's a little bit of work with finding a linearization of a function.